Hey guys, in this video, we will look at threat hunting using Garuda Framework. What is Garuda Framework? Garuda Framework is a threat hunting framework that was released at DEF CON, and it has various features. In this video, I will show you how to install Garuda, what are its features, and I'll also show you how to use it for manual threat hunting with an example of living off the land attack. In case you missed my previous video on how Garuda integrates with LLMs to perform AI-powered autonomous threat hunting, check out the video linked below in the description section. So now, before I talk about Garuda, let me give you some context and let's try to understand what is threat hunting. Threat hunting is proactively hunting for hidden or undetected threats within your organization's network. Now, it involves using endpoint telemetry, logs, or threat intelligence feeds to spot suspicious behavior or anomalies that may indicate a potential compromise. Now, when it comes to threat hunting, you can classify threat hunting into two types. One is IOC-based threat hunting and non-IOC-based threat hunting. In case of IOC-based threat hunting, you will use known indicators such as malicious IP, domains, file hashes, and so on. It is a reactive approach. In case of non-IOC-based hunting, you will focus on detecting attacker behaviors, adversary TTPs, rather than the known indicators. It is more of a proactive approach. And whether it is IOC-based hunting or non-IOC-based hunting, when it comes to threat hunting, you are mostly hunting for malicious programs used by the adversaries because adversaries use malicious programs to achieve their objective, which means it becomes important to understand how the malware interacts with the operating system. When a malware is executed, it can perform various operations, such as it can spawn a new process, it can drop files, it can set registry values, or it can perform network operations, or it can load DLL or inject code to perform malicious actions and so on. Which means if you want to effectively hunt for threats, you need a data source that gives visibility into these kind of operating system activities. One such tool that you can use to get visibility into the operating system activity is Sysmon. So what is Sysmon? Sysmon is a free tool from Microsoft, which you can download and install. And when you install, it installs a boot level startup service and it logs system activity to Windows event logs. Now, let me show you how to download and install Sysmon. To download Sysmon, visit this URL. From this URL, you can download Sysmon. And when you install Sysmon, I told you that it logs various events. For example, notice it logs process creation events, which has an event ID of 1. Also notice it logs network connection event, which has an event ID of 3. And it also logs loaded drivers, loaded modules, that is executable and DLLs. Also, if a process creates a thread in a remote process, it logs that. And there are various other events like file creation events, registry related events, WMI related events, DNS query events, and so on. It has around 29 events. Each event has an event ID associated with it. Now, let me show you how to install Sysmon. Notice I've already downloaded Sysmon. To install Sysmon, first let me copy the path. Then I will launch the elevated command prompt. I will right-click Run as administrator. And I will install Sysmon now. I will navigate to the path. And then to install Sysmon, I can use -i option. With -i option, it installs Sysmon with default configuration, default settings. But you can also optionally give a configuration file. The config file specifies the rules for tuning. In this config file, you can define which events Sysmon should monitor or ignore, which is useful for tuning unwanted noise. So the config file that I am using is a custom config file. You can also find publicly available configuration files on the internet. I will leave the link to the publicly available configuration files in the description below. Okay, now let me install Sysmon. When I install Sysmon, notice Sysmon is now installed. It installs the kernel driver and it starts the service. After starting the service, it logs all the system events to event logs. To look at the event logs, you can open Event Viewer and navigate to this path. You see here under Microsoft Windows, you can navigate to Sysmon. As you can see here under this, you will find all the events logged by Sysmon. As you can see here, it logged around 129 events. If I refresh, Notice you see around 131 events are logged, right? Now to help you understand, let's launch command.exe, which is a process creation event. Now that should be logged. If I refresh, that process creation event should be logged somewhere. As you can see here, there's one process creation event, and notice here, no, this is not related to command.exe, but there's one more here. You see here, this is related to command.exe, and it's telling me that command.exe was started by explorer.exe. But when it comes to threat hunting, you need capability to correlate, filter events more efficiently. Now, in event viewer, it is not easy to correlate or filter the events. You can still do it by using this filter option here, but it is not easy. So you need an efficient way of filtering the events. So that's where I created this tool called Garuda Threat Hunting Framework. Okay, what is Garuda Threat Hunting Framework? Garuda Threat Hunting Framework is a PowerShell-based framework that gives you the capability to correlate, filter, and investigate Sysmon events more efficiently. When you install Garuda, it provides various commandlets or commands. We call it commandlets when in PowerShell. It provides various commandlets, which allows you to retrieve all the 29 Sysmon events through PowerShell interface. In addition to that, it also gives you various advanced filtering capabilities using which you can filter attributes of any Sysmon events so that you can focus on relevant data and eliminate the noise. Also, it gives you the time filtering capability so that you can filter on relative or absolute timestamps. For example, you can filter Sysmon events for the past 15 minutes or past 5 days or past 5 hours and so on. Or you can also filter Sysmon events from a start time to an end time in both UTC and local timestamp format. In addition to that, Garuda also gives you the capability to view the output in different formats, using which you can visualize Sysmon events in a more structured manner for faster analysis. I'll show you what I mean by that. Let me show you how to download and install Garuda. Now, where to find Garuda? So you can find Garuda in my GitHub repository. Okay, so you can either clone the repository or download it as a zip file. And then to use Garuda, you need to install PowerShell core. To download PowerShell core, you can visit this URL. As of making this video, the latest version of PowerShell core is PowerShell 7.5.4, which you can install. Now let me show you how to install Garuda. On this Windows machine, I already have PowerShell core installed. And notice I've already downloaded and extracted the Garuda framework to this folder. Now, if you go inside that folder, there is a folder called Garuda. To install Garuda, all you have to do is just copy this folder into PowerShell module path. How do I get the PowerShell module path? You just run this command. This command will display all the PowerShell module paths. What you can do is you can copy that Garuda folder in one of this module path. For example, any of this module path, I'll copy this into this path. So all you have to do is just copy Garuda into the module path. So let me navigate to the documents folder, documents. Notice there is PowerShell folder. If this folder doesn't exist, you need to create this folder. And inside that, create a folder named modules. Inside that, copy the Garuda folder. Once you copy the Garuda folder, all the Garuda commandlets will be available to you. Then what you can do is you can run PowerShell core with admin privilege. Okay, that will bring up the elevated PowerShell prompt. Let me show you what are the available commands in Garuda. We already installed Garuda. Now to look at all the available commands, you can type this command because all the Garuda commandlets start with investigate verb or investigate keyword. So these are all the available Garuda commandlets. It all starts with investigate verb, we call it in PowerShell, or investigate keyword. Now notice there are various commandlets provided by Garuda. Each commandlet corresponds to a Sysmon event. For example, investigate proc info corresponds to process creation event. Suppose you want to retrieve process creation event information, you can run this commandlet. Or if you want to retrieve the DNS query information, you can run this command. Or if you want to retrieve the network connection information, you can run this. For process all the files created by a process, you can run this commandlet and so on. That's how you can list the commandlets in Garuda. Now let me show you how to use the commandlets. Let's take this example, investigate proc info. When I run without any parameters, what this commandlet will do is it will retrieve all the process creation events for the last 15 minutes by default. Let me show that. Notice when I run that, it is retrieving all the process creation events for the last 15 minutes. Okay, you see it is a event ID 1, which is a process creation event. And what you're seeing by default is called detailed view, where it is showing you list of all the attributes of this event. For example, you see these are all the different attributes. And also some attributes are created by me for faster analysis, like this one, process name, process directory, parent process name, parent process directory, and so on. These are all the different attributes of event ID 1. Let me show you the filtering feature. For example, let's say you want to get the logs for the past 15 minutes. You can use this parameter, past 15 minutes parameter. There are other parameters like you can cycle through the parameter by pressing tab, past seconds, past minutes, past hours, past days, and so on. Let me retrieve the logs for the past 15 minutes, which will give you same information. As you can see here, it retrieved the logs, process creation event logs for the past 15 minutes. I told you this is the detailed view, right? It will show you all the fields associated with this event. Now you can filter on any of these fields. That's how I have created Garuda, so that you can filter on any of these fields. For example, let's say we filter on process name field. Just give it as a parameter, process name field, command.exe in the last 15 minutes. I'm saying show me the process creation events for the past 15 minutes where the child process is command.exe, because there's a process creation event. There is a parent process and there is a child process. I'm saying show me the event where child process is command.exe. When I run that, notice it is telling me that explorer.exe started command.exe. Here is the image field will contain the full path of the process. Parent image field will contain the full path of the parent process. Now, not just that, you can also combine this. For example, let's say you want, let's say you can also combine other parameters. Like if the parent, show me where child process is command.exe and parent process is explorer, which is the same information, right? Explorer. And you need not provide the full path. You can also provide wildcards. Notice it gives you the same information. That's how you can filter on any attributes of an event. Also, you can look at the output, view the output in different formats. Now, I told you the view that you're seeing is detailed view. You can also change the view. Like, for example, let's change the view to timeline. Okay, you can cycle through different views. Okay, timeline view. Now, when I execute that command, notice the same information is presented to you in a tabular fashion, sorted by time. Notice it's easier to understand the event. As you can see here, it's telling me that explorer.exe with a process ID 4804 created this process command.exe, and this is the process ID, and this is the command line arguments. Now, the timeline view is a tabular view, because of which I could not give all the data in this view, right? Because because of the limited screen size, I could not display all the information in this view. So there is another view called timeline list view. Just change the view to timeline list. You will get the same information that you're seeing, but with more details. As you can see here, when I run the timeline list view, it's telling me that in this case, if you see the parent process, the full path of the parent process is not shown, right? And the command line arguments of the parent process is not shown. Whereas when I run this view, notice here, it's telling me that the parent process this is the path of the parent process. That is it. This is the path of the parent process. This is the parent process ID. This is the command line. And it's telling me that Explorer created command.exe and all its attributes. So you can use timeline view to get a quick understanding of the event. So if you want more detailed information, you can use a timeline list view. There is also another view called summary view, which I'll show you. Before that, what I will do is, let me show you an example. Let's launch command.exe and let me start Notepad. It started Notepad. And let me also start calculator.exe. That starts calculator. What happened? Explorer would have started command.exe, and this instance of command.exe started Notepad and calculator. Let's hunt for activity of command.exe. Now, you have many ways by which you can do it. What I'll do is, instead of past 15 minutes, let me look for the past 5 minutes. I'm saying, show me the process activity where child process is the parent process is command.exe. Let's do that. Let's change the parent process name. You can specify parent process name, parent process ID, and so on. Okay. So let me display that in the timeline view. It is giving me the activity of command.exe, right? It is still showing me all the processes spawned by command.exe. As you can see here, this process 9052 command.exe process started notepad, and the same process also started calculator.exe. Now, there is something called a summary view. Summary view will give a quick summary. For example, here, notice it's telling you that this process started notepad, the same process started calculator. If you want to get get a quick summary of everything that this process did, or all the processes this process spawned, you can run the summary view. That will tell you that this process, command.exe with a process ID of 9058, created notepad.exe, and it also created calculator.exe. So this is how you can use Garuda to filter Sysmon events. Now that you have an understanding of how to use Garuda and its features, let's use it to hunt for threats. To make it more interesting, let's consider this scenario. So this is a scenario. Your security device, let's say your security device alerted on a malicious callback connection from this IP to the command and control domain. You are asked to investigate this alert and determine the root cause. So you know that there is a communication to this command and control domain from this IP in your network. Okay, so now this is the starting point we can use to hunt for threats. Now let's see how to hunt for threats using Garuda. What I'll do is, first let me start by listing all the available commandlets. And notice there is a commandlet to investigate DNS query events. So let's use that commandlet to see if there was a communication to the domain. So let's query the results for the past days. Let's say past 1 day, or let's say past minutes. Let's say for the last 60 minutes. And then we will filter on the field called query name, because that is the field that contains the domain related information. The domain that we're looking for is K1GM something. So I'm using the wildcard. And when I run that, notice it's telling me that it's a DNS query event. There is a process called curl.exe which made a connection to this, which tried to resolve this domain. Okay, so let's use a timeline view. As you can see here, it's telling me that curl.exe with a process ID 9164 made a DNS query to this command and control domain, and it resolved to this IP address. Now, what I can do is, I can also verify if it made the network connection. So I can use this network connections plugin or network connections commandlet. Let me look at the logs for the past 60 minutes and basically filter on the destination IP. So we know that it is 146 dot something. So we will look for that 146.112. Again, you don't have to give the full IP address. You can use the wildcard. When I do that, notice it gave me these results, but this is in the detailed view format. Let's change the view to timeline. And you see the curl.exe actually made a connection. It connected to this IP address. So now we know that this curl.exe binary resolved that command and control domain. It made a connection to this IP address. Now, what is this curl.exe? The curl.exe, there's nothing called curl.exe on Windows operating system. Now we need to understand what is this curl.exe. Let's see who created curl.exe. I'll copy the process ID of curl.exe. And what I will do is I'll run this commandlet, which will retrieve the process creation information, which is investigate proc info commandlet. Check for the process ID. I'll filter on the process ID. Process. You can filter on process ID, process GUID, and so on. I will filter on the process ID. And let's look at the results. You see that it's telling me that this curl.exe with a process ID 9164, which is the one that made the DNS connection as well as network connection, this process was created by command.exe, which is a legitimate Windows operating system process. We will investigate that. But now notice before that, notice this curl.exe also was passed with this command line arguments. It's telling, notice this curl.exe was passed with suspicious command line arguments. Looks like it is downloading some content and dropping a file. Now, that's interesting. It looks like it is acting like a browser. Now, what we will do is we will verify, did it really create this file? So what I'll do is I'll take the process ID of curl.exe, and we can also investigate file creation activity. So we'll look at the file create info. Okay. And the process ID is this. I'm saying, show me all the files created by this process 9164, which is associated with curl.exe. Now that will tell me all the files curl.exe created. As you can see here, curl.exe downloaded this content, and also curl.exe dropped this file, right? Looks like the curl.exe downloaded and dropped this file. Now the question is, why did command.exe start curl.exe? So now we know why curl resolved this domain and made a connection, because to download this this file and drop it onto the disk. Okay, now what made command.exe start curl? So let's investigate command.exe, whose process ID is 8324. Let's take that and see who created command.exe. So now let me look at the process creation information, and I will give the process ID of the command.exe to see who started command.exe. And it tells me that winword.exe, that is word processor, winword.exe, started command.exe. Now what's interesting is that if you look at the command line arguments passed to command.exe, you see that it is using a variable substitution technique. You see here, the variable u is set to util.exe, and notice it is copying this file. Notice the variable u is substituted here. So this becomes C Windows System 32 certutil.exe, which is a legitimate binary on the Windows operating system. So it is copying certutil.exe as curl.exe. So I now know that this curl.exe is nothing but certutil.exe, which is a living off the land attack, where certutil.exe is used to do something malicious. This curl.exe is nothing certutil.exe. And notice then the command.exe invokes that curl.exe, which is nothing but certutil, to download this content and drop it to disk that we saw earlier. And also what's interesting is command.exe is also invokes regsvr32.exe, which is another legitimate binary on the Windows operating system, which is also used in to perform living off the land attack. And notice it invokes regsvr32.exe by passing the downloaded file as the argument. So by looking at the syntax, I can tell that it is registering a DLL. This is a syntax to register a DLL using regsvr32.exe. So that tells me that the binary that it downloaded is a DLL. So now I know what happened was winword.exe looks like user opened a Word document. There was some malicious content in the Word document which launched command.exe. Command.exe copied certutil.exe as curl.exe, and curl.exe was used to download and drop a binary which looks like a DLL. Now, another question is, why did winword.exe launch it? What we can do is, let's get some additional information by running timeline list view. That will give you the same information but additional details like winword.exe. Notice here, this is giving me the full path of winword.exe. And if you look at the command line arguments to winword.exe, notice it opened a document d.doc. As a result of opening this document, it created a process command.exe and passed these arguments to command.exe. I can verify if command.exe started curl, did it also start regsvr32.exe process? How can I do that? I'll copy the process ID of command.exe. And again, I'll investigate the process creation events, but this time I'll use this parent process ID. Yeah, I'll use this parent process ID. I'm saying, show me all the process creation events where the parent process is command.exe. When I run that, as you can see, from the command line, it should start curl and also it should start regsvr32.exe, right? As you can see here, command.exe 8324 process started curl, and this argument was passed to curl.exe. As a result, it downloaded and dropped that file. And notice command.exe also started 32-bit version of regsvr32.exe. And this DLL was passed as an argument to it. Now you can also check what else regsvr32.exe did. So let's take the process ID of regsvr32.exe to see if it invoked any process. So notice here the parent process ID is the parent process ID of regsvr32.exe. And when I look at that event, you see that this regsvr32.exe, which is this guy 6848, which is a 32-bit version of regsvr32.exe, started 64-bit version of regsvr32.exe and passed this as an argument. So that tells me that probably this is a 64-bit DLL, because of which to load the 64-bit DLL, the 32-bit version of regsvr32.exe used 64-bit version of regsvr32.exe to load this DLL. Now, I can also verify if this regsvr32.exe loaded the DLL. So, if it loaded a DLL, it should get captured in the image load event, right? So there is a commandlet which is image load info, which will retrieve all the image load events. And in this case, I'm telling show me all the image loaded by the process 3060. Okay, that is the regsvr32.exe. And when I look at the DLLs loaded by regsvr32.exe, you can see that it is an image load event, and it loaded this DLL that was downloaded and dropped by curl.exe, which is nothing but certutil.exe, right? It loaded the DLL. Now, this was a dummy DLL. I configured my environment to give a dummy DLL when curl.exe downloads this content. So what this DLL does is, this DLL, when loaded, it will invoke calculator. Okay. So if regsvr32.exe, as you can see, it loaded the DLL. If it successfully loaded, this regsvr32.exe should create calculator. We can check that. I can take this process ID and we look at the process creation event, and I'll say, show me this process as a parent. When I run that, notice regsvr32.exe actually created the calculator. So that tells me that this regsvr32.exe successfully loaded this binary, which is a DLL. So now what happened on the system? User received a document. He opened the document. As a result of opening the document, command.exe copied certutil as curl.exe, and it used curl.exe to download the malicious DLL, drop it onto the disk, and to execute the code within the DLL, it makes use of regsvr32.exe, all living off the land, all the binaries that are present in Windows operating system. So it's a living off the land attack. Now, this is whatever we did was manual approach. Okay, we did everything manually. Now I'm working on another commandlet. It's called investigate process tree. Let's retrieve the logs for the past 60 minutes. And what I can do is, I can filter on any process in the chain. For example, let's take command.exe, which is involved in this attack, right? So let's take any process ID, and when I run it, and notice it will give me the parent-child relationship of that process. You see here, it's telling me that command.exe was started by winword.exe. Now what's interesting is, if I pass this parameter, include tree parameter, it will give me the entire attack chain. Now you can tell that, okay, explorer.exe started winword.exe. And if you look at the command line passed to winword, it opened d.doc. As a result of that, I think it contained malicious macro or some malicious code, because of which winword.exe started command.exe. Now, if you look at the command arguments passed to command.exe, you see it copied certutil as curl, and curl was used to download and drop a DLL, and command.exe was used to invoke regsvr32.exe. You see here, command.exe invoking curl, and curl was used to download and drop the DLL, and command.exe also invokes 32-bit version of regsvr32.exe, and that regsvr32.exe invokes 64-bit version to load this DLL. As a result of loading the DLL, regsvr32.exe invoke calculator, because this DLL is a DLL that I configured. That's a dummy DLL that I gave to the malware. Okay. So now, as you can see, this is how you can use Garuda Threat Hunting Framework for threat hunting. This wraps up the demo on threat hunting using Garuda Framework. You have seen how Garuda's filtering capabilities and views simplify Sysmon analysis and help you focus on meaningful activity. If you'd like to see how Garuda integrates with LLMs to perform AI-powered autonomous threat hunting, check out the video linked below in the description section. And also, if you are interested in learning malware analysis, threat hunting, or malware techniques, have a look at our upcoming trainings. All the details are mentioned in the description below. Also, I'm planning to make more videos. Watch out for the upcoming videos where I plan to dive deep into more threat hunting concepts and AI-powered threat hunting. Thank you for watching and happy hunting.